So let's talk about the key role data spaces play in today's data economy. First, let's see what are data spaces. According to the Data Space Support Center glossary, a data space is a distributed system defined by governance framework that enables secure and trustworthy data transactions between participants while supporting trust and data sovereignty. Technology-wise, a data space is implemented by one or more infrastructures and may enable one or more use cases. So essentially, if we try to flesh out this definition, we can say that data spaces are digital environments designed for secure, transparent, and trusted data sharing across various sectors and participants. They possess the power to foster innovation and collaboration, allowing organizations to access and exchange data seamlessly. Also enable efficient implementation of advanced services and solutions based on this data. Moving on, the use of data spaces guarantees data sovereignty to participating individuals and organizations, allowing data holders to control the terms and conditions by which the data is reused. And finally, data spaces comprise of relationships between trusted partners. Such relationships are guarded by standards for federated, secure, and sovereign data exchange, certification, and governance. The key principles for trustworthy and efficient data sharing that are core to the concept of data spaces start with data sovereignty to ensure that data control and ownership remain with the data providers. As such, sensitive information can be protected while enabling secure data exchange at the same time. Having a data level playing field promotes fairness and equality in data access and sharing and eliminates monopolies, fostering open competition in the data economy. Furthermore, the decentralized infrastructure paves the way for interoperable distributed frameworks for secure data exchange and is in a position to support the required degree of scalability, flexibility, and interoperability in diverse systems. Finally, the presence of public-private governance can propel the collaboration between stakeholders for better and more effective policy and operational alignment. Such governance combines regulatory oversight with industry innovation to advance data ecosystems and make them able to address the current as well as the emerging needs, trends, and of course, regulations. These key principles are brought into life by different building blocks which altogether form a data space. Following the definitions brought forward by the Data Space Support Center, the design and implementation of data space compromises several building blocks, which fall under two types: the technical building blocks and the business and organizational building blocks. In this course, we will be focusing more on the technical building blocks. Those are divided in three categories. First, we have the blocks that facilitate data interoperability. Those include data models, meaning standardized structures for enabling data interoperability, data exchange APIs to enable secure and efficient interaction, and provenance and traceability services which ensure transparency and accountability in data flows. The data and sovereignty and trust category includes services for identity management and attestation, trust framework services for enabling secure and verified environments where data transactions can take place, and access and usage policy enforcement services to ensure that only authorized users have access to the data. Finally, there are data value creation enablers that include of data, services, and offering description mechanisms to promote the proper interpretation of the digital assets of a data space, the publication and discovery services, and of course, the value creation services. In the context of data spaces, we refer to participants more than to users. There are three main types of participants. The governance authority, which is responsible for creating, operating, and enforcing the governance framework for a data space. And this is actually not a user of the data space, but a management body. The primary users, which are divided to two categories, data right holders and providers, which are also called data owners, and data recipients and users, and this group includes businesses, public authorities, research organizations, academia, and anybody that consumes data through the data space. The third group is that of intermediaries, who are entities that provide services such as identity management or data catalogs. Some examples of potential users of data spaces are big data holders that want to extract value from their data, enterprises that use data for growth and innovation and desire to leverage data more strategically, businesses in a sector that want to use data to improve their sector-specific processes, policymakers that need access to data for critical decision-making, service providers that develop services using shared data, and even researchers that require access to data for their research but can also generate and contribute back data valuable for science, public or private services. But how can data spaces come to life and stay alive? As any technology platform, the path to success for a data space consists of multiple stages. Initially, there is the exploratory stage, the stage in which a data space initiative starts. Typically, a group of organizations starts to explore the interest, potential, and viability of a data space. Such activities may include, amongst others, identifying and attracting interesting stakeholders, collecting requirements, discussing use cases, or reviewing existing conventions or standards, and of course, assessing the viability and value of the data space. Such activities may include, amongst others, identifying and attracting interested stakeholders, collecting requirements, discussing use cases, or reviewing existing conventions or standards, and of course, assessing the viability and the value of the data space. The next one is the preparatory stage. This starts when the data space initiative has a critical mass of committed partners, and there is an agreement to move forward with the initiative and proceed towards creating a data space. It is typical for this stage that such partners jointly develop use cases and prepare to implement the data space. The implementation stage comes next. This begins when the data space initiative has a sufficiently detailed project plan, milestones and resources, funding or not, for developing its governance framework and infrastructure. Typically, in this stage, the parties involved in the data space and the value created for it are also clearly identified. Once the technological and governance infrastructure are there, and pilot tests have been executed, the operational stage starts. During this stage, the first use cases become operational. At this point, there is real data flowing between data providers and data recipients, and the use cases are providing the intended value. Typically, in this stage, changes occur both in the governance framework and in the technical implementation of the data space. Finally, there is the scaling stage. It begins when the data space has proven to gain new participants and embraces new use cases consistently and organically. In this stage, the data space can realistically be expected to be financially and operationally sustainable and respond to market changes and growth over time. So how many data spaces are there? According to a survey by the Data Spaces Radar, in mid-2024, there were 145 data spaces currently available, reflecting diverse use cases and implementation across multiple sectors. The key sectors represented are those targeting manufacturing with 24 data spaces, energy, mobility, and smart cities. Other sectors include health, agriculture, tourism, and more. The majority of the current data spaces are in the implementation and preparatory stages, signifying that the data spaces concept has reached the point where growth meets maturity. So why are data spaces essential for today's economy? The answer is straightforward. Once we realize that they are business drivers towards economic growth and prosperity. Data spaces can unlock new revenue streams through data monetization, with data being the new oil that is driving innovation and business growth. The European Commission estimates the data economy in the EU to be worth close to 800 billion by 2025. Organizations at the same time require trustworthy ecosystems for data collaboration, while data spaces can, apart from fulfilling this requirement, also facilitate cross-sector collaboration and can ensure regulatory compliance, for example, with the GDPR. Real-world data spaces examples that exist today and that are shining as success stories include Catena-X in the automotive sector, which is probably the most advanced data space to date, addressing challenges in traceability, sustainability, circular economy, and efficient supply chain. The mobility data space, which is a data marketplace where partners from the mobility sector can exchange data towards creating cross-company data economy to realize and further develop innovative, environmentally and user-friendly mobility concepts. The Smart Freight Center Exchange Network, which is the primary goal of promoting transparency and decarbonization in transport chains by facilitating activity and logistic and mission data exchange and reporting, and the Green Deal data space aimed at enabling secure and standardized data sharing to support the European Green Deal's goal. This data space focuses on fostering collaboration across sectors such as energy, mobility, and agriculture to accelerate the green transition and achieve climate neutrality. As it is logical, working to implement a data space or joining it comes with a lot of challenges and opportunities as well. Regarding challenges, these revolve around fragmentation in standards and implementation across regions and the currently fast-changing technological and legislative landscape, while there is still a high degree of technical complexity in achieving interoperability. Furthermore, organizations are showing a resistance to data sharing due to competition or lack of trust. And also, there is a need to find a sweet spot where data sovereignty can be a reality in shared data ecosystems. However, challenges do also come with opportunities. Today seems to be the right time to adopt state-of-the-art technologies, such as artificial intelligence and machine learning, to enhance the value of shared data, which can be realized over a data space. Furthermore, these infrastructures offer the opportunity to enhance data transparency and traceability, encourage cross-border and cross-domain collaborations, and also gain policy support by showcasing the importance of data ecosystems and calling regulators to engage.